All right, section 3.3, we continue to focus on the atom and what's in the atom. So let's review a little bit from what we had from section 3.2. Remember from 3.2 there are three pieces of the atom: protons, neutrons, and electrons. Protons are positively charged and found in the nucleus. Neutrons have no charge and are also found in the nucleus. And electrons are negatively charged, and they are found in orbit around the nucleus. And it's the electron that we are going to focus on for section 3.3. Why the electron? Because electrons have to deal with chemical reactions. Every atom wants to have 8 electrons in its outer shell. Let me say that one more time. Every atom wants to have 8 electrons in its outer shell, which means that every atom is either going to beg, borrow, or steal electrons from other atoms to get those 8 electrons. So they're going to beg, borrow, or steal other atoms to get 8 electrons. Now, every element comes with a varying amount of electrons. Some have 1, some have 8. So you can imagine the ones who have 8 have no problem. They're very, very happy. The ones who have 1 have some work to do. So this is what we're going to talk about. And the individual, getting to the slide in front of you now, the individual who kind of came up with the model of the atom as we know it is Niels Bohr. And Niels Bohr said what we've been talking about the entire time, but he's important to note. Niels Bohr said that the protons and neutrons are in the nucleus, in the middle. So the neutrons are in the middle here, this big old green blob that I'm doing. Then electrons are in orbit, very similar to the planets, around the nucleus. And the more electrons we add, the more orbits that we can get all the way around. So that's the key thing when it comes to Bohr's model of the atom, is he was the first one to say that electrons are in orbit around the nucleus. So Niels Bohr comes up with the general model of the atom, which is protons and neutrons in the nucleus and electrons in orbit around the outside. Now, when we talk about these electrons, we are going to be studying these electrons. Electrons are very much like you guys. You can be super, super hyper one day and super, super depressed the next day because it's Monday and I had to get up early and I don't feel very good and I gotta go to school. Alright? But bam! Boom! Next day! Friday! Woo! 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 Friday's awesome! Alright? So electrons are just like you guys. They go through ups and downs, peaks and valleys. That's just called energy. Just like you guys, electrons have energy. And sometimes when electrons get excited, they get really high energy, and when they kind of lose energy, they have low energy. And electrons, when they lose or gain energy, unlike you guys, when one electron loses energy, it's giving it to another electron. That doesn't really happen with you guys. If someone in your class loses energy, you're just kind of mopey on a Monday. Alright, that energy, that doesn't make you really excited. So that's kind of the difference between electrons. But when electrons get excited or aren't excited and they're kind of slow and moving around, the same thing can happen. So I want you to understand that electrons really have two states. They can be really excited, yeah, excited, woo, 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 just like you guys on like Friday. Or it can be like, oh, it's just another week again, just like you guys are on Monday. And they can be somewhere in between. So, but what we call it's a ground state, in which they're not very excited, and the excited state, in which they are excited. So that's kind of the thing with electrons. So the farther you move away from the nucleus actually increases the amount of energy that an atom has, or an electron has, excuse me, which is different from planets. So the farther you get away from the nucleus, the higher the energy an electron typically has. Now, when we talk about the electron cloud, what we're going to do is we're going to go outside on Tuesday and we're going to kind of demonstrate what this looks like on the football field so you can get a visual picture of it. But electrons aren't perfectly moving in orbit like the planets. They kind of have a cloud, and somewhere in this cloud is where they're located. So again, if I circle the nucleus in green here, the cloud is everything in red, which means that the electron could be anywhere in this cloud, somewhere. Imagine it kind of to this, and this is what makes electrons really goofy. First off, can you see an electron? No, you cannot. How fast is an electron moving? An electron is moving super fast. It has all this energy. It's like you guys. It's hyped up on tons of sugar, but it's so small, and it's moving so fast, you can't see it, and if you tried to, it's going way too fast for you to see it. Imagine that you're sitting in my classroom right now, and there was a fly in the room, but this fly had the capability to go 20,000 miles an hour, the speed of the space shuttle. And it was just doing laps around my room. Would you be ever able to figure out where it was? A, it's a fly, so it's really tough to see, and B, it's going way so fast that you couldn't see it. You know it's in my room, but you don't have any idea where it is in my room. And that's kind of the electron cloud. The electron cloud is my room, but you don't know where it is really anywhere in here, and it's hard to pick out, and we have to do some really complex mathematics to figure out where it is, and we're not going to do that, but just to kind of give you an idea of that's how it works. So, an orbital is the space where that electron's most likely to be. So, let's use this example with my fly. I have a fly going around my room, zoom, 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 really, 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 really fast. We have no idea where it is in my room. But now let's say I put a pot of honey in one corner of my room. Where is that fly most likely to be found now? In the corner of the room where the honey is. Electrons are kind of the same way. We can figure out where they're most likely supposed to be, and this place is called an orbital. So an orbital is the region of space, most likely that has the electron in that cloud. So if we go back to this picture, and we break this cloud up into fourths, like pretending it's my room, and I put a pot of honey in the corner over here, it's most likely that the electron is going to be sitting over here. So that is what an orbital is. An orbital is that place. That's that pot of honey. It's the spot where that fly is most likely going to be. Now, don't worry about these energy levels. It says the number of orbitals per energy level. Don't worry about that chart at all. All right? Do not get in a tizzy about that chart. All right. So what we do then is we know I have a fly in my room. I know it's attracted to a pot of honey. What I can do for each electron is I can come up with a configuration. And what a configuration is it's like an address for the electron. Just like each of you has an address for your house. For example, the address for the school is 9 6th Avenue Southeast, Hayfield, Minnesota. Right? The electron configuration narrows down what we have. So the electron configuration narrows it down, just like an address narrows down where the electron is. So for example, Minnesota. We know that now we're not in the other 49 states. Hayfield really narrows it down. Out of all the cities in the state of Minnesota, now we're in Hayfield. 6th Avenue Southeast, we know the exact street, and then 9 is where the school is located. If you want to get more specific, you go to the high school. Then you could do room 107, which is Mr. Clennert's room. And then you could pick a desk in Mr. Clennert's room. And we just really narrowed it down. And that's what electron configuration does. It's an address for the electron, and it really narrows things down. Lastly, we only talk about, when we talk about electron configuration, we only talk about it in the lowest energy level. Because what happens is, if we're talking about that super excited level of electrons, it gets way harder to figure out where they are, and it really complicates things. So we have to study an electron where it has the least amount of energy, and this lowest amount of energy is called the ground state. Remember, that's Monday morning, I'm moving so slow, I don't want to go to school, don't want to get out of bed, leave me alone, I'm so tired. Right? That's the phase that we just got done talking about. So the ground state is your Monday morning, where you have the least amount of energy that you're going to have. And that's where we have to study electrons. All right? Oh, I did not mean to go forward to that next slide. So that is where we're going to end. So electron configuration is the address of the electron. Electrons orbit the nucleus. And why are we focused on electrons? Because that is how things react. Every single atom wants to have 8 electrons. So that is why electrons are important to us, and that's why we have to study them.